Good evening, good morning, everyone. Welcome to today's webinar on peak cooling load and heating load calculation in compliance with ASHRAE 183 standard. We are thrilled to have you with us for this session. This webinar is ideal for HVAC designers, MEP consultants, and professionals involved in HVAC load calculation and building energy analysis. Yes, Aditya, next slide. So let me introduce ourselves. So myself, Praveen, I'll be your host today. So I'm the product marketing manager at Simulation Hub. I have around 15 plus years of experience in simulation field, especially buildings, HVAC, thermal comfort, CFD simulations. I'm delighted to introduce today's speaker, Aditya Ruikar. He's the product manager at Simulation Hub, particularly buildings AI. He's involved in developing and delivering high fidelity technology very around various industries, playing the role of domain expert. His interests lie in researching and simulating real world systems, particularly in the domain of engineering and sustainable development. So next. So for those, Aditya, next slide, yeah. For those who are new to this webinar series that we are conducting, so and new to Buildings AI, who we are, okay. So this is Buildings AI is our product. We are from Simulation Hub. I did one slide back. So Buildings AI is the product which is a agentic AI platform for HVAC load calculation and energy modeling. So it is powered by Energy Plus engine in the backend and Autodesk platform services for data management and visualization of the models, Autodesk Revit support, Revit model support, integration and everything. And AWS for cloud for running the simulation, energy simulation, and the Simulation Hub APIs, you know, yeah. So going forward, so to put it in to paint the picture, so Buildings AI is a AI powered human in loop workflows for whole building simulation. So it has for every it has tools for importing the drawing to BIM, load calculation, energy simulation, report assistant, data management. So all sort of things, including the CFD module. So in all these workflows, we try to bring AI assisted thing. So let me explain more in further slides. For example, uh, yeah, moving forward. So for example, take PDF to BIM. So this is a AI-powered agent that uses advanced image processing, computer vision, and deep learning techniques to convert your drawing or floor plan image into BIM models. So in the next, so throughout our workflow, the app, you have AI assistant which lets you interact with your BIM model, and you can query in your natural language. And thanks to Autodesk AEC data management ACDM, so that it provides all the required information, and you can execute commands, do the setup, there's material assistance, everything throughout the stage of the buildings AI, the problem, you will have this AI assistant. And towards the end, there is like report assistant, which assists you with the load calculation report, report generation, as well as the basis of design reports from from the OPR. So all sort of assistant will be there, to assist you in the whole workflow throughout the workflow. So we have been conducting series of educational webinars from the past few months, and those who have not attended those, you can always catch up. Go to this website, simulationhub.com. There under webinar section, you will be able to watch all the recordings. And in this series, we are bringing the new today's topic. Yeah, so which is peak heating and cooling load calculation and ASHRAE 183 compliance. So with this, I'll hand it over to Aditya. Aditya, over to you. You can, yeah, jump into the topic.
Okay, thank you, Praveen, for the great introduction of buildings AI and its AI assisted tools and the capabilities. So I'll start for the today's agenda and today's webinar topic. So the agenda is first we'll see what is meant by cooling and heating load calculations, why it matters, the load calculation methods to calculate it, then heat balance method, which is gold standard as mentioned by ASHRAE, and why it is so. Then understanding ASHRAE 183 requirements, what is the role of this standard, its scope, and the minimum requirements what which it puts for the this load calculation, and how buildings is in compliance with ASHRAE 183. So going forward, so first we'll see the cooling and heating load calculation, why it matters. So as all you as a HVAC designers or engineers, you might know that a best HVAC system is which can provide or maintain set temperature and humidity conditions for all your spaces. But what happens many a times is to ensure that it should maintain the better environment. People are not confident about whether it will perform its job or not. So it might happen that by adding factor of safety or by not having confidence on calculation, people adds factor of safety, and it leads to a large amount of energy consumption, and oversizing or undersizing of HVAC system may happen. So from the studies of US Energy Department, 48% of HVAC contributes the major of the building energy consumption. And if it oversizes, it is a major factor in the global warming of our today's world. And that is the challenge we are facing. So that's the issue we have. Then we'll see what is cooling and heating loads calculation. So as you may know about the spaces we wanted to maintain under temperature and 50%, or what are the design condition for humidity, for human comfort or the equipment or industrial purpose you are designing your HVAC system to. So it starts from the solar load. So solar load is the major contributor for the buildings, as solar load is coming through windows, fenestration, opaque fenestrations, then from the temperature which is outside the building, which is also driving temperature driven heat gains or heat losses based on your location. And then internal gains also contribute, then infiltration because your space might not be fully airtight, then ventilation, so whatever outdoor air you are coming to, that also adds up heat or uh, cold air from the outside, so based on your scenario. Then system generated things like fans may add heats, or there are inefficiencies that also adds to heating loads. So that is what cooling and all this heating, all these loads, HVAC system have to perform some operation to maintain your space. That is nothing but your cooling or heating load. So going forward, so we'll see how to calculate this cooling load. So the first principal thing, people go by using thumb rules or the simple calculations for the very small spaces, or like low-rise buildings or residential buildings. People can use simple formulas like Q, U, A, delta T. That is the only temperature difference which is driving heat inside your building. But for larger buildings, which are high-rise, complex, or commercial buildings, this may be inaccurate. So there are some methods like CLTD, cooling load temperature difference method, then radiant time series method, and heat balance method. So from all of these methods, heat balance method is the gold standard method, and which is accurate, but it is complex. So it is difficult to calculate loads using heat balance method manually. So there are some softwares or some computerized programs are needed to do it. So when we talk about ASHRAE's heat balance method, we are talking about the most rigorous physics-based way to calculate heating and cooling loads. At its core, idea is actually simple. The idea is like your heat inside to heat outside. Heat inside should be equal to heat outside, and the storage of your Q storage, the all summation should be 0. That is the simple principle of it. The heat balance method takes this principle and it applies to everywhere, like for your walls, to your windows, to your zone air itself, or your internal mass within a space. So Q in, Q out, and how much heat is getting stored in that building component. So that is the principle. So it also accounts for time lag. So as you might know that every component has some heat storage capacity. So it stores heat and after some time it releases. So that it also this heat balance method accounts for. So how it does is, so these equations are solved numerically at each time step, often hourly or sub-hourly, maybe 10 minutes or 15 minutes of sub-intervals we can calculate to determine how much heating and cooling is required to keep zone at its set point and humidity. So because it models the physics so completely, ASHRAE identified it as gold standard in its fundamental handbook. So that is the main principle. So there are methods available, but this is the most effective method that you can look for. So before we dive into ASHRAE 183, so here is the physics explained, how much it is complex. So as you can see, the sample schematic diagram of one space is given, how heat is conducted, transmitted, absorbed, and transferred from one component to another component, from the ceilings, wall, roofs, then air infiltration, and whatnot. So no calculation method can capture every single interaction perfectly, but some simplifications we may have to do. So if a method is oversimplifies this, it will lead to inaccurate load calculation. And if it goes for calculation for every component, so it will be impractical or computationally very heavy to calculate. So good news is that modern tools like Buildings AI, which is backed up with Energy Plus engine, are built on the heat balance method, which ASHRAE recognizes. So that's what we look forward. So understanding ASHRAE 183. So ASHRAE 183, it doesn't specify that you should go with only one method, but it suggests heat balance method. So we'll look for what is the purpose and standard of this scope. So this standard doesn't establish, doesn't say which method you should go for. It establishes minimum requirement for performing peak cooling and heating load calculations. So although there are many methods available to perform, the intent of this standard is to establish minimum level of requirement that is inclusive and possible, while it's still being restrictive enough to mandate an appropriate level of care and accuracy. And it is developed by ANSI, ASHRAE, and ACCA. So these are the well-reputed institutions from the USA. So it is collaboratively efforts taken by these institutes and came up with this standard. So we'll see what are the minimum requirements for the peak load calculation. So there are sections and subsections given in a document. I will not go into each subsection, but I have listed down the major criteria they have defined in the simplified way. So the first criteria is designer should provide uh, well accurate inputs so that there should not be any inaccuracies from input side. So weather data and indoor design conditions that should be accurate, like outdoor conditions, temperatures, humidity, solar flux, location, the orientation of building, and from indoor design conditions, owners requirements that can be discussed with owners, or owner have forwarded you in an email or any document you have provided, like sustainable. I wanted to make my building sustainable. Or if your application is industrial, clean room application, so owner's criteria might be my room should have a very list uh, uh, very list particle count or something like that. So based on owner's criteria, your design should perform. Your design should be compliance with local codes, like New York has its own code, or India has its own code. Uh, so it should comply to that also. And then comfort criteria. So who are the occupants there? So it should be comfort criteria also it should meet. Then for the cooling loads, how to calculate your cooling loads? So hourly and monthly analysis should be done, because earlier how people are calculating, they are calculating based on design dates. So only 2 days or only few days they are considering based on designer's intent. But peak can come at any hour of the year, based on your orientation or your zone direction or your operation schedules that your building is operating at. So hourly simulation should be done. Then convective and radiant gains should be considered. Then one major criteria is thermal mass effect should be also captured. Then heating load, for heating load, temperature driven heat losses you should account for, and solar and internal gains should be excluded. So earlier in ASHRAE 183 2014, if internal gains are constant, so you can consider those as well. But from 2024, they have explicitly mentioned that internal gains also you should exclude from your heating load calculations. Then infiltration effects, whether it might be heat gain or heat loss, you should consider. Then heat absorbing processes or equipments, if your space has any like cold process equipments or refrigerant might be. Then external heat gains for cooling load calculation, external here it requires external heat gains considering solar temperature driven gains. If so you're in your time when sun is very inclined, then it is important to calculate heat coming through your glass or windows as well. Then time delay it should capture. Interior and exterior shading if present. Infiltration. Then internal gains, occupants, lighting, equipment gains, and its operational schedules. And then system inefficiencies and psychrometric processes and leakages and losses you should consider. So that is a minimum criteria. But this ASHRAE 183 mostly focuses on zone loads and system loads for capacity, and you cannot completely neglect system loads. So you have to account for system loads as well. So from all these criteria, I have listed 8 key requirement categories that software should comply to for your application or your simulation or your study or design you are doing. So yeah, so those are outdoor weather data. Indoor design conditions should be accurately modeled. Solar radiations, heat gain component, thermal mass effect, occupancy and internal loads, heating load considerations, and system load calculations. So now we'll see how buildings AI is compliant to, and how can you make your design ASHRAE 183 compliant, and you can confidently go and say that whatever load calculations I am doing for my project is ASHRAE 183 compliant. At the end, designer have to sign the form that your calculations are ASHRAE 183 compliant. So will be explicitly showing you. So first thing is your outdoor air conditions and weather data should be accurate enough to model the behavior of your site, the temperature behavior and external weather conditions. So as you first create your project in Buildings AI, and as you enter your building location, the Buildings AI automatically fetch the respective EPW files and DDY files from the nearest weather station data center, and it uses in its simulation. But if you have some custom requirement, users can also import a custom weather files to do your load calculation, as well as it also note down your latitude and longitude location so that your solar radiation calculation should be accurate. The next thing is indoor design conditions. As we said, as we saw the requirements, the indoor design conditions like your set points, humidity set points, whether your space is has a dehumidification set point that you can mention in the space type details. Your heat gain components like your occupancy, your lighting load, your plenum loads, infiltration that you can mention here. You can also mention the sensible and latent bifurcation of your loads. Then you can also upload or provide schedules of your all these schedules for your all the equipments for occupancy as well as lighting and equipment, and then your outdoor air condition requirement according to ASHRAE 62.1, or if you have any custom requirements that you can mention in space type details, so that your indoor design condition should be accurate and it will be compliant to ASHRAE 183. So other than that, we have 150 plus predefined space types which are compliant with standards like ASHRAE 90.1. If you wanted to use that, you can also use those predefined space types and go for calculations. The next thing is, from a designer's perspective, the most important thing is accurately model the geometry, which is necessary and should account for all the surfaces. So all the surfaces like windows, door, roofs, floors, all these surfaces it should include. On some occasions, ground contact of your floor is also necessary. For high thermal mass, your ground may remove heat from your space during cooling load calculations. For solar load tracking, your geometry should be correctly oriented. So we have one more option to reorient your geometry if you want to. And for ASHRAE baseline simulations, you may wanted to rotate and check what are the minimum energy usage you will get for your building orientation you specifies to. Then your geometry So from interoperability perspective, Buildings AI provides options to import your building model from Revit. So we have a direct support from the Revit. And if you have AutoCAD architecture model, that also you can import to. And we have a plugin, as Praveen told. We have AI agents which can extract your geometry from PDF and convert it into Revit model, so that you don't have to take any you can be assured that your geometry can be correctly modeled. So if your geometry has the external buildings, the shading effect due to external buildings, that buildings is capable to model. Like if you see this building, it has a building side to it. So it is capable to model the external fenestration. If your geometry has defined the blinds or drapes, it can model. It is capable of modeling that as well. Then opaque building envelope and fenestration. So we'll talk to yeah. So as it is using Energy Plus in the backend, we have a both option. Yeah, whether you wanted to go for design day calculations or whether you wanted to go for the annual load calculation based on 8,760 hours, you can go for and you will get results like shown in graph here. So for every hour, you will get the hourly loads, and from that maximum is a cooling peak and minimum can be heating peak. For every zone you will get that. So the next thing is so that is about geometry. The next thing comes is accurate construction modeling. So if you are going from a Revit import model, so if whatever the material you have provided in your Revit model, Buildings AI is capable to import proper thermal properties of those from those BIM models. Also, if you wanted to change anything or if you wanted to try new materials, we have a library which has materials from different standard like ASHRAE 189, ASHRAE 90.1. So you can check for those materials and reapply those materials to your geometry. That is possible. Or even if you wanted to create a custom material, that is also possible. So Buildings AI provides the options option to define your material layer by layer, like you see in this image, and you can provide detailed properties like thickness, conductivity, density, specific heat, solar absorbance. So you can see here when you model your geometry and your materials accurately, your solar radiation calculations, your heat gain components, and thermal mass effects, all things will be getting captured for your calculations. The next thing is the accurate system modeling. For accurate system modeling, currently we have a standard 14 HVAC systems supported through which you can run simulations like AHUs with chilled water sources, then split AHUs, CAV, VAV, then terminal units like variable refrigerant flow, 4-pipe fan column unit, active chilled beam, passive chilled beam, radiant panels, unit ventilators, unit heaters, packaged terminal air condition, packaged terminal heat pumps, then water source heat pumps. All these are supported with plants are also present. So you can connect those air AHUs with the plants, hot water plant, chilled water plant, condenser plant, and variable refrigerant flow plant based on your sources, and accurately model your system so that your system loads or gains or losses can be accurately modeled. Also, in this quarter, end of this quarter, we are coming up with the exciting feature that is the aside from those standard HVAC systems, you will be able to create the custom HVAC systems of your needs from the canvas we are coming up with. So this is the new feature we are coming, HVAC canvas. So in which you can create a detailed HVAC system of your needs.
Aditya, sorry to interrupt. I
Yeah.
see Nishesh Jain's hands raised. So Nishesh, please message me in the chat, like whatever you're facing, so we can address that. Meanwhile, we'll continue with the webinar. Thanks, Aditya.
So that's about the building their workflow and how it complies with the standard. So we'll see the demo of building there. It's a couple of minute demo. So you'll get idea about the software and how to use it. So first it starts with the your project dashboard. So you create your project, provide the primary information of your project, provide site location, then import your building model or start from by sketching. As I already have my detailed Revit model. So we have a Revit plugin on ASHRAE Store that you can download and check that your Revit model is it ready for load and energy simulation or not. Then I import my Revit model. So you can segregate your envelope components floor wise, direction wise, or its component types. You can individually assign materials or with bulk selection as well. Same for space types, so that my internal design conditions and loads should get considered accurately. The next thing is zoning. So you can group your spaces under different zones, conditioned or unconditioned. Then after zoning, you can submit your building configuration. The next step is the HVAC system. So I'm going with standard HVAC system. So my zones are now visible in the on the left side. I can create AHUs and assign to those zones. And then I can look for the plants. So these are the predefined plants, but if you wanted to change the parameters and create new, that is also possible. Then I can run load simulation. So it will take 10 minutes to complete the simulation. And then you will get your loads zone wise, system wise, or facility wise, and then a bifurcation of your load with respect to envelope components or internal gains. Same for energy. Select your building configuration, HVAC configuration, and then weather file. Then it will take a couple of minutes to run simulation, and then we'll get results. So here you can see the I'm getting component wise as well as month wise data of energy. Then we have a report assistant. As simulation is completed using Energy Plus engine, the vast amount of data has been generated. You may not want to go through all that data. So whatever low calculation reports you want, you can ask to this report assistant, and it can able to generate the requirements you provided from the data from the simulation results. Those are generated. So then we have a data hub feature. So you can upload so that you can upload all your project data at a single place. These are like project management tools. Version wise, it is able to store your data. You can download your models files anytime. So that is about buildings AI. Yeah. So next thing is in summary, we'll see the compliance of compliance with ASHRAE 183 of buildings AI. So buildings AI supports the weather data and indoor design conditions as asked by ASHRAE 183. Cooling load methodology also. Then external and internal heat gains, it is capable to model as the standards suggest. Heating load methodology, so it credits for solar heat gains, infiltration, as well as peak temperature driven gains. Currently, we are in a progress to support cold process or cold process related equipments. So it partially complies. Then system cooling and heating loads. So from systems side, it accounts for psychrometric calculations, outdoor air ventilation loads, your fan and pump heat gains, then diversity of lighting, occupant and equipment, and its behavior with respect to your HVAC system. That also it is capable of modeling. Currently, it's not. We don't have an option to provide you piping, duct leakage, or damper leakage. But in the near future, will come up with it. So that's it from my side. Yeah, Praveen, over to you.
Uh,
Thanks.
thanks, Aditya, for the insightful session and the walkthrough of the workflow demonstration of the app. So we are towards the end of the webinar now, and what's next? So you can visit simulationhub.com. You can request a demo meeting with our product expert and ask you can interact with them and discover how the app can improve your productivity of your team and how it can support your sustainability goals and things. So, and alternatively, you can start your free trial. Free trial comes with 15 days accessibility and yeah. So on top of this, we have a student trial subscription. I see a lot of students in the list right now. So I see their profile. So for them, we have extended trial period of 2 months and increased credits, simulation credits. And with this, in the context of current design competition, ASHRAE Design Competition 2026, so students can benefit whoever is participating in HVAC design calculations or HVAC system selection or the net zero energy design. So they can use our platform to meet the demands of the submission, the list of submission requirements you can see, and even the first one, peak load calculations as per ASHRAE 183 standard. So this is also one of the requirements. So that is also satisfied. So you can utilize this. So you can, yeah, you can see the QR code, Aditya, next. So you can scan and start your student trial journey, or you can book the student free trial or request a demo call. We'll help you out with getting started with the platform. So with that, yes, we are coming to the end of the session. So you can post your questions uh, in the chat window, and we already received few questions. Aditya, next, I guess this is the end.
Yeah,
Yeah.
for this slide.
So I have a few questions. Okay. So which Energy Plus version are you using? Can you import IDF files? Are there any comments on this?
Yeah, IDF files. Yeah, from the development help of our development team, you can provide us the IDF files, and we can support those. But from directly from that, there is no option to import IDF files.
So right now, the supported inputs are from Revit model or AutoCAD architectural model, or if you have a floor plan, you can start from scratch. So these are the options, and the app has an inbuilt sketcher, so floor plan sketcher, so that you can use and use it. So IDF file, as Aditya says, that is kind of it needs some support, backend support to have it in the. So any comments on the Energy Plus version, Aditya?
Energy Plus version 25.1 we are supporting.
Oh, okay. Thanks. So hope that answers. And there is one more question from Louis. Uh, for the energy simulation, how can we detail values or daily, yearly profiles? How does the agentic AI help us quickly update these kind of inputs? Yeah.
Okay. So agentic AI, as I'll go to the slide. Okay. So agentic AI, how it supports is we have a building AI assistant feature in the application. So how it helps is you can ask if you are unsure about your material of your building, or which material you should use for make your building sustainable. So you can directly go and ask building AI assistant that uh, I my project is at this location, and I'm in this climate zone, and which material I should use. So it can able to suggest you materials, and even with your permission, it can directly go and assign to those envelope components. Same for the space types. There are tools we are coming up with and developing. Like if you have your data in spreadsheets or PDF, uh, or schedules, so you can provide, and whether it might be in your format as well. It might not be available in buildings AI format, but with the help of AI, it can extract that data and directly go and apply to your building model. So that's how it supports. Also, we are also coming up with the agentic workflow that automatically suggests which orientation your building should be, which material it should have, so that your building should be sustainable, or if you are applying for LEED compliant uh, LEED certification, that also it will be able to help. So that's how we are moving forward.
Yeah. Thanks. So we had few questions during the webinar. I answered them, but I just want to read it out so that others can also benefit from those questions. So this was a question from Nishesh Jain. Again, we mentioned you do full building modeling simulation, and how does this compare with established tools such as IES? Yes, the buildings AI has, it's a full building model simulation. So it includes peak load calculations, energy analysis, and CFD part right now. And we are bringing daylight and other, LCA. So all sort of things we are bringing in the next release. So in terms of methodology, what we follow and the IES follow is same. Heat balance method is implemented. They have their own engines, Apache, and then we use the Department of Energy backed Energy Plus engine. So in terms of physics or calculations, the results are same. So where we bring the differences in the workflow to make it more easy and easy to use. So existing tools are kind of has some interoperability pain points and some manual efforts in setting up the problem. It has steep learning curves as well. So we are addressing those issues, pain points with help of AI agents. So that was the question. There was one more question from Chris Flood. Does this tool perform ASHRAE heat balance method? I guess that is answered. So yes, we use Energy Plus engine and which in the backend, so which uses ASHRAE heat balance method for load calculation and energy simulation. Yes. So is any part of this calculation using AI or just the Energy Plus engine? Oh, okay. Yes, the AI is used only for the workflow improvement and the problem setup and things. The Energy Plus engine is that is the pure part. Like physics is completely taken care by the Energy Plus engine. So no calculation part is used for Energy Plus engine. Once the calculation is done, the results are available, then the AI comes in, then again, the AI can come in and extract the results and put it in a nice auto-generated report, which you can, chat with that and interact with the AI assistant and modify the format and template to suit your, design teams and yeah, so it's that. So those are the questions for now. I guess there is one more question. Let me see from Lewis. For the energy simulation, how can we do it? I guess this is the same question. Okay, these questions are already answered. What is the level of energy plus integration? I mean, can we use EMS, etc., to do runtime control? Aditya, any comments on that?
Yeah, I need to check with the technical team. So currently, I'm also not sure, but
Okay,
Nishish
okay.
will get back to you.
Sure, sure. So we have your email ID as well. We'll connect with you and answer these questions. So can I compare to AHU with different set point? Yeah, that is question from Hardik.
Yes, yes.
Okay,
You can compare to issues with
yeah,
different
sure.
segments. Yes.
Okay. Thanks for this interaction. This is making it very lively thing. So if you have more questions, please feel free to post those. Or in the chat window. Meanwhile, in the chat window, I'll share my email ID. So you can email me all the queries and then for further assistance and stuff. So this is our website. So you can visit and start your building the journey. So I don't see any more questions coming up. So thanks everyone. Thanks Aditya for sharing your knowledge about ASHRAE 183 and things. Yes, Aditya, you would like to?
Yeah. By the way, we are also open and we are organization of 200 plus engineers from CAD and the simulation background with sustainability and AEC industry expertise. So if you have any custom requirements or projects in this field, we are open to discuss. And for Buildings AI and Simulation Hub, we can leverage those APIs and provide you your custom requirements as well. So
Sure.
yeah, I'm curious to know your requirements as well. Yeah,
Thanks.
that's what I wanted to say.
And stay tuned, follow our social media handles for a future webinar announcement and any exclusive offers and things. So thanks everyone for staying till the end of the webinar. I appreciate your time. Thank you. See you in the next webinar. Bye
Yes.
bye.
Thank you.